All right, gang, I'm going to get right into today's lesson here, and I'm just going to kind of walk you through. I've already got the notes filled out, so if I were you, I would definitely fill out the notes and be prepared for the homework assignment here. So yesterday we talked about how triangles or polygons in general are congruent when all their corresponding parts are congruent, all their corresponding sides and all their corresponding angles are congruent. What we're going to talk about today is that there are shortcuts that you can use to prove triangles congruent. Okay, so just keep in mind these are shortcuts. You don't have to prove every single pair of angles and every single pair of sides. Okay, so the first theorem that we're going to talk about here, side congruence theorem, says this: if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. Okay, so if you can ever prove all three sides congruent to all three sides, you're done. You don't have to do anything with the angles because the angles fall in line accordingly. If you think about it this way, and this will be a concept that we talk about later on this year, that the sides here of the triangle are influenced by the angle and then vice versa. So the longer the side, the greater the size of the angle. If you can imagine, I open this angle up or open this side up even more, the angle opens up as well, okay? And so if the rate of these three sides is the same as these three sides, then the angles opposite those three sides have to be in accordance to or congruent to the three angles opposite the other sides, okay? Now, I see I mismarked here something. I got to figure out A, B, C, P, R, Q. Okay, so this one would have to be 3 congruency marks there. I should have that down there, okay? So you can see down here, I wrote down a congruency statement based off the understanding that these are congruent by side, or SSS. And I went ahead and did A to B to C, okay? So 2 to 3. And if it's PRQ, okay, we're going from 2 congruency marks to 3 congruency marks. A, B, C, P, R, Q, okay? Now, I did write something else down here that you're going to need to memorize. This will be a question on your test, and it's the acronym CPCTC, okay? And we're going to continue to practice this to get this idea down, but CPCTC stands for this, that corresponding parts of congruent triangles are congruent, okay? So once I've proven the triangle's congruent, what then do I know? Well, I then know that angle A is congruent to angle P because they correspond and they're within congruent triangles, okay? So corresponding parts of congruent triangles are congruent. I then know that angle B is congruent to angle R, okay? Because they correspond and they're in congruent triangles, so they have to be congruent. And likewise, angle C is congruent to angle Q, okay? So again, memorize that CPCTC, all right? What that means. Now, this next part, again, we're talking proofs here, and that's why I'm kind of walking you through this. A flow proof uses arrows to show the flow of the proof, okay? And so as I look at the first part, we're told that triangle QRS is isosceles. And what isosceles means is that you have 2 congruent sides. And so they went a step further and said, hey, QR is congruent to SR, okay? That's the given. Now from here, it also tells us that RT bisects QS. Okay, now what do we say bisects means? It means to cut in half. So if RT cuts in half QS, we then would know QT and QS would have to be congruent because this segment was cut in half. Both parts of the segment have to be congruent. So over here, if you notice, I put down that it was bisected, and then the result of that bisection, okay? I just noticed here, must have been half asleep when I was doing the proof here. Definition of bisects is what I should have here, okay? So QT has to be congruent to TS because RT cut it in half, okay? So those two are congruent. Now, again, I talked about this yesterday, but I want to stress it to you that if you have a side length, TR from this triangle is the same TR from this triangle, you have to state that it's congruent to itself by the reflexive property, okay? So what does that then mean? Well, if you look here in this triangle, I have this side's congruent to this one, this side's congruent to this one, that one's congruent to itself. So the triangles are then congruent by side, 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 okay? Now, I did add an extra step. You would not need this step if you're proving this. Remember, we always finish with the proof, okay? But I went a step further just to say, hey, by CP/CTC, again, notice I proved I have congruent triangles first, okay? So back up here, where I gave the acronym, corresponding parts of what type of triangles? Congruent triangles. You have to have congruent triangles before you can claim anything else is congruent. So what I have here, I have congruent triangles by side, side, side. So by the fact that they are congruent, I know that all of their other corresponding angles, these, let me get back up here, these two here, these two here, and these two here would have to be congruent by what reason? CP/CTC, okay? So corresponding parts of congruent triangles are congruent. Now, this next one, I should have put the acronym here, and I didn't. SSS, okay? So side angle side congruence theorem says this: if two sides and the included angle, so I want you to see this here. I've got two sides that are congruent. The included angle has to be the angle between those two sides. If it's not between the two sides, it's not included between them, okay? So if two sides, the included angle of one triangle, are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Again, this is by side, angle, side, okay? So what I did here, again, I went back to ABC, and I'm looking at the congruency marks now. 2 congruency marks to 1 congruency mark. So I'm going to come over here, RQP, 2 congruency marks to 1 congruency mark, okay? So again, match up those corresponding parts there with that congruency statement. Now, once you're done, again, by CP/CTC, you could then prove that angle A is congruent to angle R. You could prove angle C is congruent to angle P. You could even prove that AC is congruent to PR, all right? And all that would be true because the triangles are congruent, so by CP/CTC, all their other parts have to be congruent, okay? If you grasp that idea of CP/CTC today, you will be way ahead of where we need to be right now. Okay, so we are going to go ahead and use this kite over here, and I know it's really hard to see the kite, so I'm actually going to go ahead and redraw the shape separate of everything else. I'm going to mark down E, D, F, and G, okay? And we're told that DE and FE are congruent, so I'm going to mark those two congruent. And we're told that EG, this segment here, bisects angle DEF, okay? So what I did was when I was looking at this proof, I noticed that this segment was shared between both triangles. So I marked it congruent to itself by the reflexive property, okay? So GE is congruent to GE by the reflexive property. Now from here, I went back to my proof and I saw this word bisects, okay? So if GE is bisecting angle DEF, what's the result? Well, if I cut this angle in half, I've got 2 equal parts of the angle. So I wrote down angle DEG is congruent to angle FEG by the definition of bisects, okay? Now if I mark that in my picture here, what I notice is that my triangles are congruent. I have side, angle, side. Side, angle, side. Remember that included angle has to be between those 2 congruent sides. And so I went back to my proof and I said, hey, the triangles are congruent, what I'm trying to prove, by side, angle, side, okay? Now you'll notice I went one step further. This did not need to be stated, okay? All I had to do was prove the triangle's congruent, but I went ahead and said, you know what else would be true because the triangles are congruent? DE is congruent to FG, again by CP/CTC. Corresponding parts, these parts correspond, of what type of triangles? Congruent triangles, which they are congruent, okay? I could have went in and said angle D is congruent to angle F, or I could have said this angle here and this angle here are congruent, again, by C, P, C, T, C, okay? All right. Now, to finish things up, I wanted to show you a couple of things here. First of all, we have this graph down here, and it's saying, hey, I have a triangle ABC, and then I have another triangle EFG, and we want to know if those two triangles are congruent to each other. In the coordinate plane, the only thing you can do to prove congruency or lack of congruency is your distance formula, okay, using side angle side, or side, sorry. So what I ended up doing was this. I went back to my Pythagorean theorem, and I even simplified it even further than the simple formula by undoing the square here. I square rooted both sides. When I square root both sides, this is the equation that I have for the Pythagorean theorem, okay? So when I came back down here, and I'm looking at, I want to know the length of AB, I can make a right triangle like this right here, okay? This length is 2, this length is 1. So I plugged in the two lengths, 2 and 1. I squared both of them. 1 plus 4 is 5, and I square rooted it, okay? For BC, if you look here, I'm going to go up 2 and over 2, okay? So I'm going to go 2 squared plus 2 squared. That'd be 4 plus 4, which is 8, and I'm square rooting that. Again, that idea of the square root of a squared plus b squared, okay? So, not very hard. I get the length of BC then. For AC, I'm over 1 and up 1, 2, 3, 4. Okay, over 1 and up 4. So 1 squared is 1, and 4 squared is 16. And if I add those together, I got 17. So square root of 17 is the length of AC. Okay. Now, as you look, I went ahead and did the same thing for the other triangle. I've got one side congruent. I've got another pair of sides congruent, but my third sides are not congruent. So as a result of that, I have the triangles are not congruent because not all the corresponding sides are congruent, okay? So I know that was very quick. I hope that made sense to you. Your questions can be found in Schoology or at the bottom of the first page. I'm not sure if I use these same problems that I have here, but if I go to my not that one. If I go to this one here and look up Schoology, there we are. I'm going to go up here, right here for Wednesday, 13, 15, 17, 20. Yeah. So I'm pretty sure you're probably going to have at least a proof on the homework tonight. See what you can do with that, and we'll come back tomorrow and take a look at it. So, hey, thanks for following along with me. And let me know if I can do better to communicate that sometime. So we'll talk to you later. Bye.